Hello everyone, I am Bhagyalakshmi, Department of Mathematics, SNS College of Technology. Today we are going to discuss about the paper matrices and calculus. Under this, the unit 2 orthogonal transformation of a real symmetric matrix we are going to discuss. Under this, the first topic is diagonalization of a real symmetric matrix. Transforming a real symmetric matrix A into D by means of the transformation n transpose an, that is equal to D, is known as the orthogonal transformation. Here D is the diagonal matrix and n is the matrix whose columns are the normalized eigenvectors of A. Based on this, we can check on diagonalized sum. So we can question is diagonalize the matrix here 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3 by means of an orthogonal transformation. So the matrix is given. We want to calculate the diagonalized matrix by using the orthogonal transformation. So first we can choose the given matrix as A. So A equal to, we are choosing the given matrix. After this, we want to calculate the term. After this, we want to calculate the terms characteristic equation and characteristic equation, eigenvalues, eigenvectors. Up to that process we discussed earlier in the previous videos. So same these two values we need for the diagonal to calculate the diagonalist matrix. So the orally we can check. First, calculating the characteristic equation, that is the general term is lambda cube minus c1 lambda square plus c2 lambda minus c3 equal to 0, where c1 equal to sum of the main diagonal elements, that is 8 plus 7 plus 3 is 18, and then c2 sum of the minus of the main diagonal elements. So first main diagonal element, first my diagonal value minus plus second diagonal value minus plus third diagonal value minus. Adding all these three values, we are getting the value as 45, and the third value is C3 is determinant of A. So determinant of A already we learned in our school days itself. So easily we can calculate all those values. So calculating C1, C2, C3 in substituting that equation, the C3 is equal to 0. So we get only these values. Lambda cube minus 18 lambda square plus 45 lambda equal to 0. In this lambda we can choose it out. So we get one value directly, lambda equal to 0. Another value is, here we got the quadratic equation. So from that quadratic equation we got the roots 3 and 15. So from that, for this cubic equation, the lambda values are 0, 3, 15. So these from this up to lambda values are derived. Next we can calculate the eigenvector for this corresponding lambda values. So the first thing is we want to write the general term for the eigenvector a minus lambda I into x equal to 0. So a minus lambda I, for this term we can conclude, if we concluded the diagonal alone having that value as with the minus lambda. So the 8 minus lambda, 7 minus lambda, 3 minus lambda, these values we get. So from this we can easily rewrite this a minus lambda I. So from this equation, first one by one we want to substitute all the lambda values. So lambda equal to 0, I am taking the first value. Okay. So lambda equal to 0, substituting instead of 0 we get this matrix. In this matrix we can go for the I am choosing first two equations. So in this first two equations we got the first value minus second value. Next, first value minus second value. First value minus second value. Like this, we can calculate. So, first x1, x2 and then x3. From these cross values, we are getting all the values. So, if we write all the values, we get easily instead of this x1, x2 and x3. So, if we cancel all the values in the common term, we get x1 equal to 1, 2, 2. So, we got the first eigenvector. Like this, we can move on to the next second eigenvector, lambda equal to 3. So, lambda equal to 3, we can substitute in the given eigenvector common term. So, we get the values here. So, 8 minus 5, 8 minus 3 equal to 5, like that. In the diagonal alone, which got the different values, and each and every equation is different. So that